Now let's look at how we do the determinant of a 3x3 matrix. On the right hand side we have our calling function, the left hand side we have our subroutine. So the calling function uses the same values that we used in the example we seen earlier. So we have a matrix and it's 7, 2, 1, 0, 3, minus 1, minus 3, 4 and 2. So whenever we work through, we should get the results that we see here. So the final answer for the determinant of this 3x3 matrix should be a value of 1. And it works it out as per the example here. So we have our A, and then we find the determinant of the EFHI minus B, and the determinant of DGFI plus C, and the determinant of DEGH. So let's go ahead and we'll have a look at it in the actual program, and then we will load it into the machine and see it running. So in the program we have the matrix here, we have the location where we're going to save the final result, and we're going to jump to the subroutine. So now it's the subroutine det3 and it's at this address. So we jump into the subroutine here, run through the subroutine, and it returns the result back to det1 to the location det, and then we end the program. So now for the actual subroutine, it's not particularly pretty, but it's effective and it gets it done. So we're really just using the same principle we used for the determinant for a 2x2 matrix, but we just expand it and we pick out the values that we require in order to generate the result. So now we're going to have 9 values. So we read the 9 values in as per the previous one, and those get read into A, B, C, D, E, F, G, H and I. So that should G, F, G, that should say H. Okay, so that's us loaded in the memory locations of the 7, 2, 1, 0, 3, minus 1, minus 3, 4 and minus 2. But remember, it's just the memory locations, not the actual values. And then what we can do is we can go ahead and we can pull out the values in the correct order and do the multiplications and additions and subtractions. So in this instance here, we've pulled out the value of our I and then the F, and we've done the multiplication, the E and the I, and we've done the multiplication, E times I, and then the F and the H, again we've done the multiplication, F times H, then we've subtracted to get the E times I minus F times H. We've then drawn out the value for our A, and then done the multiplication again. So we've ended up with the very first value here that we require. And then we can move that value into another register. So I've moved that into the index register. And then we can work through the same process, but the next process is going to be the D times I and the F times G. And then we multiply it by the value of minus B. So we've got the B here, and to generate minus B, we subtract it from 0. So that gives us the minus B. And we go through the multiplication and we get this term here. And then what we do is we add that value onto the value in the index register. So now the index register is going to have the first two parts of the determinant. And then finally we work through the final part of the determinant, working out D times H and E times G. And then we multiply it by the C. And then again we add on to the value in the index register. So finally the value in the index register has got the full value for the determinant of a 3x3 matrix, which is this little equation here. And then we go ahead and we store the value into the memory location pointed to by the contents of register R5, which is going to be the location DET, okay, for the answer. And then we finish off the housekeeping, we replace all the original values into the registers, so the CPU is back to exactly how it started before we went into the routine. And then we jump to the return address, so this is us jumping up here, and the program ends. And that's the end of our code. Now there are other ways of writing this code that would make it a little bit neater, and we do have other commands there that are available to us in order for us to do that. But it's nice just to see it written out simply, and it's a very easy way to explain it and using this method. So let's go ahead and we will see the actually working within the CPU. So I have loaded the subroutine into the ROM and the program into the RAM. So let's see it running. Now, if this works out correctly, it should give us the result of a value of 1, and it will save that value of 1 in the memory. So let's see it working through. And it's probably going too fast for you to recognise any of the numbers, but that's it counting up the memory locations to save the values to. And you see some of the values heading through here and doing the multiplications. And then that's it finished. It's replaced all the registers back to 0. So it's worked through it relatively quickly. So we'll stop the simulation and we will head in and have a look in the actual RAM to see where the result is stored. So this is the matrix here. So the matrix is the first row 7, 2, 1. Then it's got 0, 3, and I think it's -1, and then the other 3 here. And the final answer will be in the next memory location. So that's the next memory location there, which is a value of 1, which is correct. So it has worked through and it has generated the determinant of a 3x3 matrix. So let's move on to the next video and we will look at transposing a matrix. Thank you for listening. I'll get you on the next video. Goodbye.